What is the most used man-made material on Earth? You guessed it, it's concrete. Look around, it's everywhere. You see it in sidewalks, driveways, foundations, floors you stand on, and even entire structural building frames are made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. All right, welcome to another episode of Concrete Logic Podcast. Today, I have
Bryant Wheeler with Polycrete USA.
Yeah, so we're going to talk about insulated concrete forms. So Bryant, could you give a little bit about yourself, a background and
Sure.
what Polycrete does?
Sure. Okay. Myself, I've been in the construction industry for too freaking long, at least 40 some odd years. My first ICF job I ever did was in 1982. I thought it was a great concept. Didn't fare well. Had problems with the project. Had multiple blowouts, but I still thought it was a great concept. Then I tried another one that had metal in the form. It was called Ice Block. Didn't have a bit of problem with that, but they're no longer around. But they were also a smaller form. I'm the vice president of Polycrete USA. We've been in the Richmond area for about 12 years now. We are very successful in the multifamily and the commercial field more than anything. Since we started doing pre-cut, we've gotten into the residential field about 50%, where it used to only be about 10% residential.
I gotcha. And is the product, the ICF forms, are they manufactured locally, or where are they manufactured?
We manufacture ours at our plant in Canada.
Oh, okay.
We're looking to put a manufacturing plant in the area here shortly, as soon as the economy warrants it. ICF's been around for about 30 years, and basically what ICF is, it's an insulating concrete forming system. It's most of them are 2.5 inches of foam on two sides. You fill it with concrete and steel, and you get a structural wall that stands up to 250 mile an hour winds. It has an R23.25 insulation factor. It's a continuous installation. It's got a 4-hour fire rating. And it's an absolute quiet system. It has an STC from 55 to 57 rating, which is for the sound that's let in and let out of the building.
Yeah, and Bryant wanted us to meet at a building that used ICF, and I went by there to check it out before, and unfortunately they liked their music. It was very loud in there, so I thought it was going to kind of kill the atmosphere for a podcast. But you were right. When I was inside that building, you could not hear the traffic or anything outside. As soon as you walked in, you could kind of see it. And then from the outside, you couldn't even tell it was an ICF.
Well, it's concrete. You can do anything with concrete.
Right.
I mean, you can make it. You can shape it to whatever you want. So it can look like a conventional building and still be a structurally sound, extremely durable building.
Yeah. And so ICF is essentially formwork that stays in place, right?
Correct.
So you would form up a wall just like you would form up a wall, how we typically form up a wall with, wood or a pre-made steel form.
Right.
So that's what ICF is. But you brought me a section today, and it has, like you said.
If you want to pick it up, I'll explain it to you.
Yeah.
All right. I can get my ass up. Oops. Sorry.
You all right?
All right. So this is just a sample. This is normally 8 foot long.
Right.
All right. So the other sample you saw earlier from the competitors, that's the longest are typically 4 foot long and 18 inches high. Ours are 8 foot long and 2 foot high. so it goes in much quicker. It's all pre-cut for you. We have steel ties, not the plastic garbage that blows out and breaks when the concrete flows through.
Yeah, we're gonna have to be very good at explaining, since our folks can't see what we're looking at. But if you could explain what you and I are looking at right now.
All right, everybody, close your eyes and deal with me a minute. All right, so inside the 2.5 inches of foam on both sides, we have steel strips that run every 3 inches. And then we have a fastening strip for attaching your sheetrock or whatever you're going to put on the exterior of the building every foot high in the form. We tie the 2 pieces of foam together by a piece that protrudes through the foam and steel ties that go from one side to the other, and it's all welded. And the hinging system allows the form to be collapsed so you get more in the shipping than what standard is already pre-assembled, to the point that it's wider. It'll be about, the smallest is going to be about 10.5 inches. So imagine getting something that's 10.5 inches on a truck versus 4 inches on a truck.
Yeah, so we got 2 pieces of foam here, which is what we're saying, 2-3 inches thick, 2.5, and then those pieces are connected by what to me kind of looks like almost like wire mesh thickness of what do you guys call this? Steel. But it looks kind of like the pattern of wire mesh, and then it's hooked to these hooks that are coming out of the insulation, the 2 pieces of insulation.
Right,
and that's
those
what
hooks
connects.
are welded to the fastening strip and the wire that's inside the foam.
Right, yeah. So you got a section cut out here, and you can see that there's quite a bit of steel that's in there, and it looks like again, it kind of reminds me of wire mesh that's embedded within the insulation, and that's what is.
Most contractors, they'll look at this. Oh wow, you got a fence all the way around your building embedded in the foam.
Yeah, that's a good visual. Yeah, it's like a fence. But it's pretty cool. So, and then the pieces collapse together, and you're saying 8-foot section is a typical.
Yep, 8 foot by 2 foot. We also do 18 inches high, and we also do 1 foot high. And the stuff is pre-cut, so we can rip it to whatever the end height's going to be on your building.
And then it looks like it has kind of like a tongue, like a tongue and groove top to it, and then the pieces just kind of stack on each other.
Yep, we have ties that snap in. It pushes everything out in place, so it locks it all, and you have a nice flush wall. We also have inserts that you want to increase from an R23 to an R30, an R50, or something like that. Mm-hmm. We call it the R stack, and it slides right down the center. And they're also 8 foot long, and you just drop them in there, and our ties will snap and hold them in place, so you don't even have to screw them in. It goes.
So you would put more did I hear you right? More insulation in between here?
Correct.
Okay.
We would widen the form by whatever, if the concrete's got to stay at 6 inches.
Okay.
We widen another 2 inches, so you'll have 8 inches of a cavity. You'll end up with your 6 inches of concrete and an extra 2 inches of foam on the inside.
So it's a sandwich.
Correct.
So it's like the outside forms are like the bread on a sandwich, and then you're putting if you put in another piece of insulation there, it'd be like the meat, and then you would snap that meat in place, right? With or the stain
with the
like
expanders.
Expanders.
You snap them with the expanders.
Okay.
And these are the seats for the rebar. Inside of it.
So and what size rebar do you typically see in your wall?
Typical standard is usually number 4, number 5.
Okay.
A lot of the commercial buildings, we end up doing a lot of number 8 and number 9 rebar in the wall. Secured buildings that we do for the government is mostly all number 8, number 9, and we've even done some with number 12 rebar in the wall.
Oh wow!
And yeah.
So you got they're just straight, long, standard pieces of rebar,
just like you do it conventionally.
And then you fish it down and set them on these chairs.
Yep.
They look like chairs within the wall. And then, how tall can you build these things before you start putting concrete in them, I guess?
Typically we go floor heights. So if it's a 14-foot floor, we'll stack the forms up to 14 foot all the way around the building.
Okay.
Next day, come in with the concrete and the pump truck, and we start pumping, and we'll have that 14-foot tall wall poured by the end of the day.
Right.
So all your concrete's placed, all the rebar's in place, and the beautiful thing is nobody comes back and strips the forms.
Yeah, no stripping.
It's there.
Yeah,
so that's 15% savings right there.
Right. Yeah. And your insulation's in place.
And the insulation's in place, yes.
Right. Yeah, that's pretty cool.
You got an air barrier, a moisture barrier. You have the insulation value. You have a wall that's going to stand up to 250 mile an hour winds plus. You have a high R value of it starting out at R22.35, and it's a continuous insulation. And it's concrete. Concrete's been around forever. It's going to be there forever. Mm-hmm. I mean, people put down foam, but in this case, the foam's going to be there forever, not in the landfill forever.
Yeah.
So there's big pluses to it.
All right, and then so you would do like we were saying, you would do a floor-to-floor height worth. So you're coming up off the foundations, and you go up to the first elevated deck. You would stop your walls to that point, right?
Correct.
And then you would, you said pump concrete in there. Now, is there like a flow rate restriction or anything with this versus a regular formwork that we would have to?
No,
be careful of?
You treat it just like your regular formwork.
Okay.
Don't do that with every ICF.
Right.
With ours, because we have the steel, you can do it.
Right.
Do not do that with other ICF. You got to pump it slower.
Yeah, the piece we were looking at in the parking lot had plastic. It was very, very thin plastic, versus what you brought me today. The Polycrete stuff, it has steel in it, and then like we mentioned before, the other one with the plastic in between didn't fall flat either.
Correct.
So you're saying that one has a flow rate restriction as far as how fast you can
Yes.
fill the forms up?
Yes, and height.
And height,
yes.
too. Okay.
Yep.
So I imagine, well, let's do this. Can you talk about what an ideal project? We were talking offline, and we were talking about what type of projects I'm typically involved with. And you were asking me, how come I hadn't looked at ICF?
I asked you, why the hell haven't you used ICF? You're right. That's what I asked you.
Yeah. And so could you give us an ideal project that you're like, that's an easy ICF solution that we could kind of keep our eyes out for? So
yeah, multifamily is the big saver, right?
Okay.
Multifamilies in hotels. Mm-hmm. Because typically for your firewalls on a multifamily, they're expensive. With ours, you use a 6-inch concrete wall, and we put a taper top on the top of it, so it gives you a 10-inch berth on the top, so that you can actually set your concrete floor systems on top of the ICF wall. Mm-hmm. So, and it just continues to go up instead of something that's going to be an average for a party wall of around 12 inches. Now you're going to have something that's going to be 10 5/8, and then the sheetrock goes on the outside of it like a conventional wall. So you have a 4-hour party wall versus what they were looking for, a 2-hour party wall. Mm. So it's a big advantage in that sense, plus the speed. Everything's pre-cut. If it's done with CMU block, picture, 18 CMU blocks takes the place of one Polycrete ICF form. So all those motions, picking that block up and setting it in place and mortaring it in place has got to get done. Mm-hmm. Well, all you're doing here is you're setting it in place, someone's setting the rebar right behind you. Next day, you're putting concrete in the wall.
Gotcha.
So you're going to save money up front. You're going to use a smaller HVAC unit. You're going to save money on your long-term loan that you're going to be using to build a building with, because it's going to cut the construction time by about a third. So it's just a smarter way to build, a safer way to build, a cleaner way to build, and much, much faster.
Gotcha. Do they... I'm just, when you're talking about this, I'm envisioning exterior walls.
Okay.
On a project, what do you do for interior walls? Is it the same? Would you do ICF there, or would you do something different? Or
we've done office buildings where the walls were all ICF inside the building and the exterior. Mm-hmm. That's not typical, though.
Okay.
They did it for sound reasons. They didn't want sound transmission from one office to another office.
Right.
But so of course, yes, you can do it. It's got to be in your budget to do it. It's got to make sense
right.
to do it.
So, like a multifamily or a hotel, you would do ICF on the exterior, and then do you typically see like a metal stud or
Okay,
as
so
far as dividing walls?
Yeah, so the hotels we do, the majority of them are all the exterior walls ICF, and then every other interior wall becomes ICF.
Oh, okay.
So then that's where your firewalls are going to be, is every other unit. So we make those the ICF walls, and then they'll have a steel studded wall in between.
What about the elevator shafts? Are they
elevator shafts? Some of them we make ICF, some of them they remain doing with CMU block. We have a form called the V1, which is plywood on one side and foam on the other side for elevator shafts, and then the plywood gets removed.
Okay.
But right now, because of the cost of lumber, it doesn't make sense.
So you're probably seeing some block.
Yeah.
I imagine.
Yep. We're not going to talk you into something that's going to cost you money. That's for sure. We're going to talk you into something that's going to save you money.
That's what I'm saying is if we could, like you mentioned, what an ideal project is. I think your counterpart Bruce I talked to before, he told me like a 4 or 5 level multifamily or hotel.
Yeah, that seems to be the sweet spot. Between 4 and 7 stories.
Yeah.
Yep.
Versus something shorter or maybe something taller.
Well, I mean, the tallest one in the United States is 22 stories.
Oh, wow. Where's that?
And that's in Florida. 2 buildings in Florida. Harry Pinkleton was the installer on that. And he's actually doing a job for us right now in North Carolina. He needs to retire. He's getting old. I think the tallest one in Canada is 30 stories. I'm pretty sure that's what it is, but I have to look back.
I got you. So, I was sharing with you, we're in Richmond, Virginia, and I learned about this, it was maybe 5 years ago, 4 or 5 years ago, and honestly hadn't heard about it anywhere else. I've been in the Midwest and Mid-Atlantic mostly in my career. Where do you see ICF used a lot? Like
New York City.
New York City.
We do a lot of construction in New York City, multi-stories. Along the coastline, down along the Gulf Coast into all the way out to Texas. And then schools, like Kentucky, all their schools are being built out of ICF.
Oh, wow.
So, I mean, that's a big plus for the industry overall.
Yeah.
But schools are also ideal to build out of ICF, especially with morons out there using guns and shooting up schools. You can't shoot through the concrete.
Right. Well, I think that's good for places that are prone to tornadoes or hurricanes.
Oh, absolutely, yes.
Yeah, versus building them out of.
Yeah, it'll stand up to tornadoes and hurricanes.
Yeah.
And it'll stand up to fires, but you don't want to stay in the building. You still want to evacuate. You know, I mean, don't be an idiot and stay in there.
Right. So we talked about a typical or an ideal project for ICF. And you mentioned you're doing a little bit more residential now.
Yes.
For residential projects, what are you seeing as far as you're talking single family home residential or multifamily?
Well, multifamily, we've been seeing that, like in Connecticut, multifamily is considered residential. New York is considered commercial. So you have these different categories, whatever state you happen to be working in. But when I'm talking about simple residential is single family units, and we've really increased our output for building single family units. That all started with the pre-cut, when we started doing pre-cut, which is beautiful because everything comes to you. Windows and doors are all cut out. Everything's just ready to go.
Right. So you get a set of plans and then do your pre-cut.
Oh yeah, you get a set of plans and it's row by row, tells you what form goes where. The forms are labeled, and according to what the plan says, they're all labeled. And the label that's going to be put on the form shows the actual cut. So you can double check measurements if you need to.
Right. Yeah, I see, I forgot his last name, but Dominic up in Connecticut. It's always posting on LinkedIn. ICF looks like single family homes being done up there.
Right.
Is it typically for like areas where they have basements? Is that?
No.
No, not necessarily?
No. For the longest time, people thought that ICFs could only be used for basements. And it was just out of ignorance, just not knowing and not understanding. Because typically people will put a concrete basement in and then they'll do stick framing on top.
Right.
So that's where it's stuck in their head that it's only for basements. But For example, right now we have several houses going that are complete ICF, and we have a couple that are just the foundations. So it's pretty much left up to the customer. We obviously try to talk the customer into building smarter, but you can't always do that.
Right. Well, yeah, especially right now, everyone's sensitive to material pricing and things like that, and they're looking in the short term versus long term value. It's always with concrete is you got to.
Well, we've always been right along the same price line as stick construction. Now we're less costly than stick construction, and you're getting a far better building.
So it's probably more of not knowing that this is
available. That's what it is. Most general contractors are kind of afraid to change and try something different. It's not new. It's different to them. It's been around for 30 years.
Yeah, because they have a set group of subcontractors.
I've been building with CMU block for the last 50 years. I ain't changing.
Right.
That's
what they know how long that schedule is. Right. They're comfortable with it. As far as an ICF building, I was share a little bit about me. My dream is to have a concrete house at some point in my life. So I'd like to build a concrete house. So I was checking on YouTube of a fellow that built his. He's out west somewhere, maybe in the Southwest, and he was very open with his cost and the pros and the cons of an ICF building. And the only con that I heard was he had, I guess, humidity issues within his house. So he had to have like some kind of dehumidifier.
Dehumidifier now?
Yeah. Because it might have been because he was in the Southwest or something. And
someone didn't do their job right when designing the house. Because that should have been handled with the air handler.
Yeah, so it's probably the big difference between the outside temperature and the inside temperature. So it's so good at insulating what's going on inside that the difference is probably why he had the issues.
Yeah, typically you're not going to have that problem.
Yeah.
Typically the humidity is kept outside the house, and your air handler will get rid of the humidity in the house. Now, I don't know what the guy does, if he cooks a lot or boils a lot or has something illegal going on, who knows, but you shouldn't have a humidity built up in the house.
I don't think it was anything illegal. It was
I'm just kidding.
It was a guy that used to be actually I think a civil engineer or something like that, and he built his own house using obviously ICF and things like that. So that's it was interesting to see that. So we talked about the history of ICF. What do you see coming for ICF? Any changes? In the
United States, I honestly see ICF taking about 60% of the industry in the next 10 years.
Wow.
Simply because the cost of lumber right now has gotten people to open their eyes and look at alternative ways of building, and they're liking it. And they're realizing the benefits that they get from it. So I think in one way the economy has been good for ICF.
Yeah, no, I think that is one of the good things coming out of such an inflationary environment on the standard or traditional materials that we've been using for building. It's getting people to look at other options, which hopefully pushes the industry to new technologies and new ways of building, because obviously we can't keep building the same way and expect people to pay for it.
Right.
So.
It really is up to the architects, the owners, the developers to educate their general contractors. Besides us trying to educate the general contractor, because they think we're trying to push a product.
Right.
Architects know better. Developers know better. It's hard to get a general contractor to change from his common practice, but they're kind of being forced to do that today.
Yeah. Oh, one thing I forgot, as far as how this ICF construction impacts other trades, like your mechanical, electrical, plumbing guys. How does their putting in conduits and that sort of thing? How does that work for ICF?
Okay, it's pretty simple. An electrician can either run conduit down inside the wall prior to the pour, and breach the ICF for your outlets. Or you can hot wire, which is a way of cutting the ICF, and you tuck the wire inside the foam, and then you refoam back over it once the wire's in there. I like the latter better. It's quicker, it's simpler. Electricians love it. The first time they do it, they're afraid, that it's going to be different. But then when they can just walk down with a hot knife and route out the foam and tuck the wire, and it's much easier than getting on your knees and drilling holes in every stud or knocking knockouts out in every stud and running wire.
Yeah.
So it's quicker, it's simpler, it's cleaner. They love it. Plumbers can plumb either in the concrete or in the foam. For marriage walls, sometimes we'll thicken the wall in the plumbing area so they can run all their stink pipe or whatever they have to run inside the foam instead of going into the concrete. So on a marriage wall, you're actually able to have plumbing on that marriage wall because you're not going to breach the concrete, so you still have your 4-hour fire rating.
Oh, wow. So you can actually, in the field, cut outlets and things like that. There's no, I'm sure there's amount that you don't want cut in the form, in the insulation.
Yeah, but we handle that ahead of time. If I go over plans, if I see anything that's being done that needs to be corrected, I let the architect know and I let the owner know. And we find a workaround at that point, no matter what the situation is. It can always be solved.
Yeah.
It's foam and it's concrete.
Yeah.
You can do whatever with foam and you can do whatever with concrete.
Yeah. Yeah, because that's cool. Because there's some prefab materials out there that are being touted as the new green thing, and talking to some folks that built those, they said, hey, you got to really plan ahead as far as any openings and things for MEP trades, because you can't cut holes in it when it gets to the field.
We can, but it's a lot harder. Yes.
Yeah.
Yes.
Yeah.
So we basically do the same thing. I'll talk to the plumber, or we will talk to the plumber, or talk to the electrician, or talk to the HVAC guy, and know where they're going to breach it. Our installers will breach the wall for them if they can't be out there in time. They just have to locate it, and we'll do it where they ask us to locate it. We work with all the different trades. We stay with the contractor and the owner throughout the job. So let's say they're 90% complete and they have a question. Give me a yell.
Right.
I'll help you out.
And you guys, just to make clear, you guys just provide the formwork, the design, the engineering, not necessarily doing the construction of it. You work with contractors. So if there's a concrete contractor listening to this and they run across this, they would work with you as far as shop drawings and things like that. Is that typically how it works?
Yes, sort of. We have different ways of working with the public, and we have trained installers that they can hire, and they can pay directly. We have the ability to supply one crew chief to go on the job and run their crew, their concrete guys, or we can work alongside their crew so that they can learn how to do it for the next building. So there's many ways of doing this. We do not do the engineering. We engineer our form, yes.
Yes.
We do drawings for our forms. We'll take your drawings and convert it into ICF drawings. And we'll do all the cut sheets for you. You'll have all that by the time you're ready to build. So everybody knows what's going on. We will draw out your footing, where your footing's got to be, and the dimensions for it. We have a starter track that shoots down to the footing, which keeps the forms nice and straight and plumb. We're the only ones that do this. And we give you the dimensions for squaring up your foundations. So you don't have to figure all that out. It's given to you. The reason we do that is because it's got to be exact, because the pre-cutting is exact. It's within 30 seconds of an inch on your pre-cutting. So if you start off wrong, you might end up 2.5 inches too long on one wall or 2.5 inches short on one wall. So you got to follow instructions, and it's not hard. It's all spelled out for you.
Gotcha. Yeah, it sounds like the process is just like when a concrete contractor works with a formwork, say a Doka or a Perry formwork supplier. They do all the shop drawings for us, and we take those, submit those to the architect and engineer, and then they sign off. They review.
Sort of different. We take the architecturals and the structurals and we'll take those drawings and convert them to the ICF and make it a concrete building. Mm-hmm. We'll ask, do you want to keep the interior dimensions or you want to keep the exterior dimensions? Because now you're going from possibly a 2x6 wall or a 8-inch concrete or block wall, and you're going to change it to a wall that overall is going to be 10 5/8 inches if it's 6 inches of concrete on the inside. Mm-hmm. So we find out what dimensions you actually want for your interior rooms, and we work with you to make it fit. For our job, sometimes it just doesn't work because our walls will be too thick.
Right.
And you just got to pass up that job.
Right. Yeah, there's an ideal job for each type of system. So that sounds great, Bryant. If folks want to reach out to you after hearing this podcast and want to learn more about Polycrete and ICF, how do they get a hold of you?
First, the best thing to do is go to polycreteusa.com. It's POLYCRETE-USA.com. Or you can pick up your phone and give me a call. My cell phone is 804-901-6893. And you can call me up to 9 o'clock at night. I don't care. That's fine.
Somebody might take you up on that.
That's fine. If I'm dreaming and you woke me up on the couch, deal with it.
All right, Brian, I appreciate you coming on the podcast today.
I appreciate this.
Yeah, this is fun.
The public needs to be educated.
That's right. That's what this is all about, promoting concrete and concrete technology. So I appreciate you coming on today and spending time with me. Hey everyone, I hope you enjoyed today's episode of Concrete Logic Podcast. If you did enjoy, please hit subscribe on your favorite podcast listening app and share with others that you would think would find value in the podcast. I look forward to having more discussions. Please tune in and we'll see you on the next episode of Concrete Logic Podcast.